And now, in this video, we're going to look at properties of logarithms again, but now instead of expanding, we're going to condense. So this is the idea where we are given multiple logarithms, and we really want to write it as a nice compact expression. So we're undoing what we just did in the previous video. So when we do this, again, we are going to try to combine it into a single term, but we must have same base logarithms. Okay, if we don't have same bases, no go. When we expand, we're going to actually follow the same process as we did for, when we condense, we're going to follow the same process as we did when we were expanding. So again, we're going to try to use the power law, but now it's in reverse. So if we have any coefficients, we want to write those as exponents on whatever's inside. Then after we do that, if we see a quotient, or if we see a difference, so a subtraction, we're going to write that as a quotient. And then finally, if we see a sum, we're going to write that as a product. Okay, so here we go. We want to condense each of these expressions. So first thing I'm going to do is just make my life easier and write log of e as ln, okay, minus 1/3 x, 1/3 ln x squared, and I'm going to remember my equal signs, okay, because we're simplifying expressions. Next, okay, now I'm going to just go through my process. Power law. Do I see any coefficients? Yeah, actually, the 1/3, right? So this is going to be ln y minus ln, and then when I simplify this, this is going to be to the x to the 2/3. And if you need to remember y, laws of exponents, and please, please, please review those. Okay, now use the power law, okay, and then next I ask myself, is there a quotient or a difference? And I'm going to say yep, so I'm going to do that. So this subtraction is ln of y over x to the 2/3. And so this is, notice that the quotient is inside the logarithm, okay? Common error, okay? Watch out for this. And I guarantee you're going to do this at one point or another because there's a property that you're going to try to use incorrectly. There are a lot of students that will write this as ln of y over ln of x to the 2/3. This is not true in this case when you're condensing. The quotient must be inside the logarithm, okay? Cannot stress that enough, okay? Then at this point, is there anything else I can do to condense it? Can I use the power law? Nope. Can I use a difference law? Nope. And product of sum? There's no sum, so can't use that. So I'm done here. That's my final answer. Natural log of y over x to the 2/3. For the next one, I want you to pause the video and try it on your own. And for this last example here, I paused the video and I worked it out. So again, I'm just kind of going through this checklist of power law, difference law, product of sum. Okay, so first thing, can I use a power law? Are there any coefficients? And in fact, there were. There was 3 and there was 4. So I brought those inside as exponents on the expression inside. Okay, and so did that for both of those, moved on with my life. So then I noticed that there was indeed a difference. There was a difference here and a difference here. I wrote the first difference as, so it'd be x cubed over x, or t to the 4th. Okay, so that's good. Now this one I did not incorporate into the previous expression, or the previous logarithm, right? I didn't introduce another quotient. And that is actually true because if we notice, the bases are not the same. So I said you have to have the same bases in order to do this. Okay, without it, can't do anything. So actually log base 2 of y is going to just stay out there. And then lastly, I used the product of sum because I did have a sum here, and so that just multiplied 2 to that expression in there to put it in the numerator. And I'm done. Okay, so that is condensing in action. So again, you're given multiple logarithms, and if they have the same bases, you can work on combining them into a single logarithm. All right, so that's going to be the end of this one, and here is another quiz question for you to try.